Okay, number 11. Tanner is a poultry farmer who raises chickens and turkeys. He has spaces available for 500 birds on his farm, but he wants to have no more than 180 turkeys. I'm jumping to the question, how many of each type of bird? So that tells me how to define my variables. So I'm going to let X be the number of chickens, and Y can be the number of turkeys. One thing that I've read so far is he has 500 spaces available for birds. So if I add up all of the chickens plus all of the turkeys, that better be less than or equal to 500 because he only has 500 spaces available. Yes? Yes. He wants to have no more than 180 turkeys. So the number of turkeys needs to be less than or equal to 180. Suppose it costs him $1.50 per chicken and $4 per turkey to feed each to maturity, and he has $1,600 available. So if we do $1.50 times each chicken plus $4 times each turkey, that needs to be less than or equal to the $1,600 he has available, or the bird feed budget. The farm can sell the chickens. So this is where we're getting into revenue or profit. They can sell the chickens for $3 and the turkeys for $8.25. And we are trying to find how many of each bird needed to maximize the profit. So I want to maximize the profit, which it said is $3 for each chicken plus $8.25 for each turkey. All right, and so setting up the linear programming problem, we're maximizing this profit subject to these restraints, and then of course X has to be positive or equal to 0, and Y has to be greater than or equal to 0, because it doesn't make sense to have a negative amount of birds, correct? Mm-hmm. Okay, and so this is my linear programming problem. So, as I said before, on the test, if it's the big problem, you're not going to have to set it up and solve it like this one. You will have to set up a problem and stop. And so if it's set up a problem and stop, this is where you stop. This is your linear programming problem. But if it's solved, it will already be set up for you here, and you just have to label your variables. So we have X and Y. P is our profit. I just added that one as I was writing that. So to do a linear programming problem, what we do is we add slack variables. And so X plus Y plus S1 will equal 500. The next one, Y plus S2 will equal 180. 1.50X plus 4Y plus S3 will equal 1600. So we have 3 slack variables going on. So I'm going to write out what they are. S1 equals, S2 equals, and S3 equals. So S1 was talking about this one right here. That was how many spaces they had available. So that's leftover spaces. How many spaces they had available for the birds right there. This one was specifically talking about no more than 180 turkeys. So this would be leftover turkeys. And S3 was talking about bird feed budget. So money for bird feed. Leftover. So these are my variables right there. I got 6 of them going on. Okay, after we rewrite them with slack variables, we are then going to move everything to the left of our objective function here. So I'm going to have negative 3x minus 8.25y plus p equals 0. Now I'm able to put this into a tableau. So I'm going to have x, y, s1, s2, s3, p, and then my constants. My objective function is going to go below the very bottom horizontal line. And then the 3 equations will go in the middle. All right, so once we have our initial simplex tableau, so this is our initial simplex tableau. So if we're kind of looking over here, part A was set up the linear programming problem. That was part A. This is part B, set up the initial simplex tableau. Circle pivot element. So I'm going to find the most negative number, which is negative 8.25. I only divide the positive number. So if any of these are negative or 0, I would just put an X beside them. So 500 divided by 1 is 500. 180 divided by 1 is 180, and 1600 divided by 4 is 400. I go with the smallest quotient, which makes that my pivot element. It is in row 2, column 2. I then need to pivot. So this is where I need to go to my calculator and plug this in. This is a 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7. Say 4 by 7 matrix.
Wait, why did you divide that?
Okay, so once you put this into your matrix in your calculator and you run your simplex program, then you have to decide, are you finished? By looking at the very bottom to see if there's any negatives left. Are you finished?
Nope.
No. How many negatives are there? 1. What column is it in? Column 1? Okay. Then tell me what the numbers are.
1, 0, 3 over 2, negative 3.
Okay. So you just need to write down the negative column and then the constants, which are
320, 180, 880, 1,485.
all right. So I've got my negative column, I've got my constants. So I'm not finished, there's still a negative on the bottom. This means I need to pivot again. So I just write down the crucial stuff. So when it says show your work and each new matrix or new tableau, this is a new tableau right here. So this is the most negative column, is the only column. So I know I'm column 1. Looking above the bottom line, not all those numbers are positive. If there's ever a 0 or a negative, you just put an X beside that one. It's not the winner. So I have 320 divided by 1, which is 320, and 880 divided by 3 halves, which is, anybody do that one yet?
It's like 580 something.
580 something.
586.
So the 300 one is smaller. So that makes row 1, column 1, my pivot element. So I go through the program again and I pivot on row 1, column 1. And then you ask yourself, am I finished?
Yes.
And you answer yes, because there's no negatives in the bottom row. Okay, so now we're going to write out our final tableau. And oops. Trying to cheat a little bit here by writing this down, but I'm having a hard time. Cut. I'm gonna do it over here. Paste. Oh yeah, let me do it there. So this would be our final tableau. So notice I don't write down the ugly columns. I just cross them off because no need to write them down and then cross them off. And so this tells me that S1 equals 0 and S2 equals 0 because those are my ugly columns. Reading across row 1, I have 1x equals 320. Row 2, I have 1y equals 180. Row 3, I have 1s sub 3 equals 400. And row 4, I have p equals 2445. So then, putting in my answers here, it said, so his profit is $2,445, and it happens when he has, X was chicken, so 320 chickens, Y was turkeys, so 180 turkeys, and then leftover resources, S1 was 0, S2 was 0, but S3 was 400, and S3 was leftover money for bird feed, and so I have $400 left over for bird feed. Yay, and there's a super long problem, start to finish. So number 12, Mason buys an old Ford Mustang for $9,000. He pays $1,500 down, so that's important. That is cash, that does not go in your calculator ever. So whenever you have a down payment, the first thing you do is figure out what the loan was. If he paid $1,500 down, but it cost $9,000, then $9,000 minus $1,500 is how much he paid down on this car. So that would be $7,500. Yes. Okay. So that's our loan amount. And so I'm gonna come over here and put all my stuff going on. All right, and so the loan is for negative $7,500, but he's gonna pay it off. So the future value is 0. Interest rate 6.1%. Compounded monthly, so PY and CY are 12, and N, which is M times T, is going to be 12 times 3 years. And the very first thing it asks is, what are his monthly payments? So I'm going to solve for his monthly payments. So on my calculator, I'm going to go to Apps, Finance, TBM Solver, and I'm going to type this stuff in. 12 times 3, interest rate 6.1, present value negative 7,500. Payments we don't know, so I'm just going to skip it. Future value 0. PY and CY are 12. I'm going to put it back up on my payment and hit alpha enter, and I get $228.50. So monthly payment $228.50. Then it says how much interest will he end up paying. So that's bad interest. That means you're going to pay back a whole lot more than you borrowed. So it's going to be what he pays times the number of times he paid it minus what he borrowed. So he paid $228.50 every month for 3 years minus the $7,500 that he borrowed. So 228.5 times 12 times 3 minus 7,500. So he's going to pay $726 interest. Is that what you're about? Alright, so 2 years ago, Cooper purchased a snow cone shop for $54,000. He finances the entire thing. So that means he did not put any cash down on it. That means his entire loan amount is $54,000, which I have to enter in as a negative number. Go ahead and write the rest of my stuff here. Okay, he finances the entire thing at 5.27%. That's my interest rate. Compounded monthly for 15 years. So PY and CY are 12. N is M times T, which is monthly times 15. Future value of the loan is 0 because we're going to pay it off. Okay, what is the current outstanding principal? So that means how much does he still owe? How much does he still owe? Even if it didn't give you the hint there, every problem you do, first thing you do is solve for payment. Okay, so we're going to solve for payment here. And I'll put all this in. Apps, Finance, TBM Solver. I have 12 times 15, 5.27, negative 54,000. Don't know my payment yet. Everything else is good. So I'm going to hit alpha enter. And I get $434.66 for the payment. All right. So define the current outstanding principal, which is how much he still owes. You change your N to how many payments have already happened. He's been paying every month for 2 years. So he has made 24 payments. After 24 payments, his future value will not yet be 0. He won't have it paid off yet. So we're solving for the future value to see how much he still owes, which is his current outstanding principal. So I'm going to go back up to N and change it to 24. and then I'm gonna go to future value and hit alpha enter. So after 2 years, he still owes $49,012.42. Number 14, Piper decides to start a savings account that is compounded weekly. So I'm going to go ahead and write my stuff down right here. It's compounded weekly, so that means PY and CY are 52, and N, which is ILM times T, is going to be 52 times something. At 2.4%. If she puts $20 a week into the account. So if it was a one-time deposit, that's present value. If it's repeated, that's payment. So I'm gonna put -20. How much money will she have after 9 years? So we're solving for her future value. It didn't say she put any money in there to begin with, so our present value is 0. So I'm gonna put all this in, I'm gonna solve for future value. Oh, my time, just kidding, 9 years, right there. So for my N, I have 52 times 9. And my interest rate is 2.4. Present value is 0. Payment's -20. Looking for the future value, PY and CY are 52. So I put my cursor back up on future value and hit alpha enter. And I get how much money she had after 9 years is $10,445.09. Then it says how much interest will she have earned. That's the good interest. That means you're going to end up with way more money than you put in yourself. So you start with how much you end up with, your future value. Minus, you subtract what you put in, which is either you may have just put in a present value, or if you were making payments, then it's your payments times the number of times you made that payment. And so in this case, it's payments. So our future value is $10,445.09 minus $20 every week for 9 years. So I'm going to have 10,445.09 minus 20 times 52 times 9. And so interest earned would be $1,085.09. So number 15, it says, David figures he can afford a car payment of $280 a month if the interest rates remain at 5% a year. So I'm going to go ahead and write down my stuff here. So he can afford payments of $280 a month. So that's -$280 going to the people who gave him a loan. At 5% interest compounded monthly, so PY and CY is 12, and N, which is M times T, will be 12 times, and I see right above that, 6 years. If he plans to put $4,000 down, that's cash. That does not go in your calculator. We'll deal with that in a second. What is the maximum price car? What is the maximum price car he should even consider? So he has $4,000 cash, right? And he's going to also take out a loan. So if we add that to his loan amount that he can afford, that the loan that he can get for all this, that's going to be the maximum price car that he should consider. So we need to put all this in and solve for present value, which is the loan amount. So future value would be 0, and we're going to solve for present value. So I'm going to go to Apps, Finance, TBM Solver, type in my 12 times 6, and 5, come back to present value, -$280, 0, monthly, and I want to solve for present value. So the loan amount he can afford, if these are the payments he can afford, then the biggest loan he can take out is $17,385.98. So I'm gonna add that to 4,000, and we get $21,385.98 is the maximum loan that he could take out. Josh, number 16, Josh inherited $50,000 when he turned 21. He decides to open a savings account with it. Good for Josh. So he's gonna put this one-time deposit into a savings account. So that means it's a present value. Write down my stuff. So he's gonna put $50,000 into the bank. So that's negative $50,000 because it's going away from him into the bank. Okay. He decides to open a savings account with it. He wants to have $1 million by the time he retires. So his future value is going to be $1 million. That would be 6 zeros. He retired at age 65. So he's 21 now. 65 minus 21 is 44. So that's 44 years go by. It is compounded daily. So PY and CY is 365. And our N, which is M times T, will be 365 times 44 years. Interest rate is 2.25, and we are wanting to know how much money would he need to put into the account each day to reach his goal. So that's our payment. And then it says how much interest would he earn. So I'm going to put this in, apps, TBM solver. I'm going to go up here, and I'm going to have 365 times 44, 2.25, negative 50,000. I'm going to solve for payment. 365 for my PY and CY. Oh, future value, $1 million. All right, and so our payment, alpha, enter. So negative 50,000 because it's going into the bank. Also, payment comes out negative because that's going into the bank. So they're both going the same direction there. So his payment that he needs to make each day is going to be $31.55 each day. And then how much interest will he earn? That's the good interest. So that's going to be how much he ends up with minus what he put in. So he ends up with $1 million. But what he put in two big things, right? He put in $50,000 at the very beginning. And then he also put in $31.55 every day for 44 years. So he put in two things. He put in a present value and he put in a payment times in. So I'm going to come over here and do 1 million minus 50,000 minus, not times, minus 31.55 times 365. Alright, so we have 1 million minus 50,000 minus 31.55 times 365 times 44. Enter. So he earned a lot of interest here, $443,307. It's not too bad. So he has $1 million, and he really only put in about half of that. The other half is interest. So on number 17, it's this PTA problem. I just changed the name of the school. So back over on announcements here, where it says more Simplex practice problems, number 4 is the PTA problem. So you can watch number 4 video if you need help with it. And then the review has different numbers, so you can kind of just see how you do on that. But I already have a video made of how to do this PTA problem just with different numbers. So I am gonna move on to 18. 18. Kaylee takes out a short-term loan for $11,500 compounded weekly. So I'm gonna put this down. So a short-term loan that goes in for my present value. I'm gonna pay it off, so my future value is 0. It's compounded weekly. So PY and CY are 52. N will be 52 times 5 because it's for 5 years. Yes. How much interest will she end up paying on this? Oh, somewhere 8.3% interest rate. And the question is, how much interest will she end up paying on this loan? So that's the bad interest. That means she's going to pay more than she owes. So that's going to be what she pays, her payment times the number of times she pays it, minus the loan that she borrowed. So in order to find how much interest she ends up paying, we have to first solve for payment. So I'm going to type these in. Finance, apps, TV home solver. 52 times 5, 8.3. Alright, put my cursor back up on payment and hit alpha enter. Did y'all get 54.08? Did y'all not get 54.08? Yes. So for our payment we have $54.08. So interest that she'll end up paying, she's going to pay $54.08 every week for 5 years minus the loan. So 54.08 times 52 times 5 minus 11,500. And she's going to pay interest of $2,560.80. Questions on that one? Okay, you might not have started 19 yet, but I've already gotten lots of questions over it, so I'm going to start it so I can finish the video at least with 19 included. If you haven't started it yet, just ignore me because you should try it on your own first. And I just recorded all that, so yay. There we go. Okay, 3 friends get together and invest in their own coffee shop. The coffee shop costs $310,000 and they plan to put 15% down. So the very first thing I need to do is find their down payment. So 15% of $310,000, 0.15 times 310,000. $46,500 is the down payment they're putting down. That's cash. That does not go in your calculator. Once you figure out how much they're paying in cash, you can then figure out what? How much their loan is going to be for. So the loan is going to be the total cost of this place minus the cash they're paying. And so their loan amount is going to be for $263,500. All right. So right now I know my loan amount is negative 263,500. I know my future value is 0 because I'm going to pay off the loan. It is 3.4% compounded monthly for 30 years. So 12 times 30, PY and CY are 12. First thing I'm going to do is solve for payments. So I'm going to go to Apps, Finance, TV home solver, and I'll type this stuff in. Going back up, I'm going to solve for my payment. I get 1168.57. So 1168.57.
How'd you find what?
Yes, anyone, yes?
Yes.
Okay. How much, this is the question I keep getting asked, how much of their very first payment went toward the loan debt? So what we do here is we need to change our in to how many payments have happened. One, their very first payment. After one payment, their future value will not yet be zero. So after one payment, solve for the future value to see how much they still owe, their current outstanding principal. So I'm gonna come up here and change my n to 1, and come down here and solve my future value, alpha enter, and so they did owe what was in the present value there, but now they owe 263,078.01. Okay, so this is their current outstanding principal, how much they still owe.
When you do this current outstanding principal, is like you change the n and then do always solve for f one.
And so to find out how much of their very first payment went toward their loan or debt, look at it. This was the present value, this was the loan, but this is now the loan. So you need to subtract those two. So for part B, you need to do 263,500 minus 263,078.01. So I'm going to subtract the two. I'm just going to do it right here. 263,500 minus, and you get $421.99
So we have to withdraw.
went to the loan. But if you look at part A, they paid a lot more than that. They paid $1,168, but only 421 of that went toward the loan. So the rest of it went where? Interest. So for part C, how much went toward interest? That's going to be their payment minus how much went toward their loan. So 1168.57 minus 421.99. 746.58. That is their how much went toward interest. All right. So it says how much, so those are kind of in their own little world that usually gives people trouble right there. But that's part B and C. After one payment, how much of the first payment went toward debt, how much of it went toward interest. Then part D, how much interest will they end up paying over 30 years? That's just a basic, how much interest do you pay? So that's going to be their payment times N minus their loan amount. So that's going to be their payment, 1168.57 times 12 times 30 minus 263,500. So I'm going to have 1168.57 times 12 times 30 minus 263,500. So $157,185.20 is how much interest they will end up paying. Part E, how much do they still owe on the loan 5 years after they bought the shop? All right, so this is another one that causes people trouble. So you want to change your N to how many payments have already happened. They've been paying every month for 5 years. Solve for the future value, and it'll tell you how much they still owe. And so I'm going to go back to my apps, finance, TVM solver. I'm going to change my N to 12 times 5, and I'm going to come down and solve for future value. And so after 5 years, they still owe $235,943.58. So And then the last one, if they decide to refinance their shop 5 years after the purchase with a 15-year mortgage, blah, 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 how much are their new payments? So our N is now gonna be monthly times 15. Our interest rate will be 2.95. The present value will be how much they still owe after 5 years. Payment is what you're solving for. Your future value will be 0, and PY and CY will equal monthly. So you want to put this in your calculator, and we get 12 times 15, 2.95, negative 235,943.58, and solve for payment. And so their new payment would be $1,623.72.